So this is from Unit 5, Accumulation, Net Change, and the Cauldron. This is a demonstration that I did live in class, but because I have so many people absent, I thought I would go ahead and record it as a video so that you could watch it, or you could watch it again. This is Accumulation, Net Change, and the Cauldron, and I drew a cauldron. Cauldron is just a bucket or a pot, something like that. And then I put an amount of something in. And so this is the initial amount. This is the starting position. This is where we begin. This is at t equals whatever the first thing is you're trying to do in the interval. Sometimes t equals 0, whatever, initial amount. And then often they will tell us that water or something is flowing into something, a bucket, a cauldron, at a rate. And this rate is rate of t. So this is rate of change. So this is the derivative. And it usually has units like liters per minute. So if you integrate the rate of change between some time to some time, you're going to get the net amount that's added to the cauldron. It's not going to tell you how much is in the cauldron, it's just going to tell you how much was added to the cauldron, right? Because if you integrate liters per minute, you're going to end up with liters, right? And then sometimes they also say, hey, water is dribbling out, something is leaking, something is pouring out, whatever, at another rate. And I just called this d of t, right? Still another rate of change. So that if you were talking about the integral from that's the amount that would be coming out of the cauldron. So a lot of story problems then can be written about this cauldron problem, right? That the cauldron could be particle motion, and the initial position would be the initial amount, right? And then the displacement would be the net change, right? So if you wanted to know the position of a particle, you would need to know where it started, the initial, and then you would add displacement to it, right? Or you can do any problem that's related to this. So what does this look like notationally? Well, if I want to know how much is in the cauldron, right, I've got to start with how much is in the cauldron. So that's usually the function at t equals 0. So I'm just going to say initial amount, and then I'm going to add the net amount that goes in the same amount of time, and I'm going to take out the stuff that dripped out. And then at the end of all of that, that should give me what's left in the cauldron. So continuing on with this concept of net accumulation, we talk about the definite integral. And so when we have a definite integral, right, of f of x dx, f prime, sorry, when we integrate the derivative, we end up with the function, right? So we end up with the function from a to b. And I know I'm working backwards, but this would just be f of b minus f of a, right? So if we're talking about time, this is the initial, right? This is what's given, and this is what we're supposed to be, is what we're supposed to find. So in other words, find minus given equals net change. This is the net change part. Right, so to use that to do problems, switch to blue. This is from your homework. This is problem set 5.14, I think. We start off with find. We're trying to find y of 3. We were given an initial value, y of 1. And then to do the net change, we're going to integrate y prime from 1 to 3, right? So we're going to put this part in our calculator, right here. That's math 9. I think it's something like function int for integration. And then we have y3 equals, well, what is y of 1? Y of 1 is 6. 6 plus, and then if I put that in my calculator, I get 4.666, which is 2/3, right? Right. So how much do I have at the end? Y3, I have 10.6666, 10 2/3. So the last thing I talked about in class was, what does this look like in a free response question? And so what ends up happening is that you have something that looks like this. G of x is equal to this integral. And one of the questions that they ask is find g of 4, right? And so you put in 2 to 4 of f of t dt, right? And you are given a graph. And then it usually has something like triangles and squares and semicircles, right? And so you find that information. But the other thing that it tells you is that G prime is the second fundamental theorem of calculus, right? You put the x in for the t, so this would be f of x times the derivative of x, which is 1. And then they tell you that this is the graph of f. And then they ask you about G prime. So the next video goes into more detail about that. But this piece, every time they give you something like this and a graph, you need to write somewhere on your paper, G prime of x equals f of x. So this is it. That's what I talked about in class. Watch the other videos. They're important, especially if you're on distance learning. Thanks.